Let us start our module 4. In module 4, we will discuss about inverters. Inverters are circuit which is used to convert DC power into AC power. The input of an inverter is DC and output from the inverter is a variable voltage, variable frequency, AC power. Okay, there are different types of inverter: voltage source inverter, and current source inverter. In this chapter, we will discuss about single phase voltage source inverter, three phase voltage source inverter, and current source inverter. Okay. Inverter is a circuit that converts DC power into AC power at desired output voltage and frequency. The output from the inverter is variable AC voltage, and variable frequency AC voltage. Some applications of inverters are: we can use an inverter for speed control of AC motors. The system which is used for speed control of AC motors are known as AC drives. So a AC drive usually consists of an inverter. Okay. Also, these inverters are used for induction heating, and it is also used in uninterrupted power supplies for computer. Uninterrupted power supply is UPS. Also, it is used in HVDC transmission lines. Okay, these are the major application of an inverter circuit. Inverters are used in AC drives, and it is used for induction heating, and it is used in UPS, and also it is used in HVDC transmission lines. Okay. In previous modules, we already discussed about different types of rectifiers, phase controlled rectifier. At that time, we studied that if we are varying the firing angle alpha greater than 90 degree, we can use this rectifier in its inversion mode. So at that time, the phase controlled rectifiers are known as line commutated inverter. If firing angle alpha is greater than 90 degree for a phase controlled rectifier, at that time the phase controlled rectifier act as an inverter. At that time, the phase controlled rectifier is known as line commutated inverter. Okay, but we can't use this phase controlled rectifier as a isolated independent AC voltage source, because it need a AC supply for its commutation purpose. That is the input. That is this line commutated inverter require a AC supply for its commutation purpose. So we can't use this phase controlled rectifier or this line commutated inverter as a independent isolated AC voltage source, or we can't use it as a variable frequency generator. Okay, because it consists of an AC. It need a AC supply for its proper operation. But in this voltage source inverter, the input is a DC. We are converting the input DC into variable frequency, variable voltage AC. So usually this voltage source inverter required forced commutation. Usually this voltage source inverter or current source inverter requires forced commutation. Voltage source inverter and current source inverter consists of controlled switches. These controlled switches require forced commutation for the proper operation of this voltage source inverter and current source inverter. In this module, we will discuss about this forced commutated inverter. Okay, that is the difference between the phase controlled converter and inverter, voltage source inverter and current source inverter. In voltage source inverter and current source inverter, we are employing forced commutation. Okay, next is the classification of inverter. Depending upon the type of output wave shapes, inverters are classified into square wave inverter, quasi square wave inverter and sine wave inverter. Then depending upon the nature of input DC voltage, depending upon the nature of input DC voltage, the inverters are classified into voltage source inverters VSI and current source inverter CSI. The voltage source inverter in which the DC source has small or negligible internal impedance. The voltage source inverter has DC voltage source at its input terminal. But in the case of current source inverter, the current source inverter has DC current source at its input terminal, and in the current source inverter has high internal impedance. Okay, in this inverter circuit, in the voltage source inverter or current source inverter circuit, we can use a thyristor as controlled switches. If we are using a thyristor as controlled switches, the thyristor requires a forced commutation circuitry for turning off the thyristor. Before turning off the thyristor, the thyristor requires a forced commutation circuit. But if we are incorporating a GTO means gate turn off switch. If we are incorporating a gate turn off switch as controlled switch in voltage source inverter or current source inverter, the inverter circuit requires a negative gate current pulse to turn off the controlled switches. Okay. That type of inverter circuits are known as self-commutated inverter. That means a self-commutated inverter does not require any commutation circuit. But if we are incorporating a thyristor as controlled switches, the thyristor requires a forced commutation external circuitry to turn off the control switches. Okay. Usually the voltage source inverters are forced commutated inverters. Okay. From the viewpoint of connections of semiconductor devices, inverters are classified as bridge inverter, series inverters and parallel inverters. In this chapter we will discuss about single phase, half bridge inverters, single phase bridge inverters and three phase bridge inverters. First we will discuss about single phase voltage source bridge inverter. Single phase voltage source bridge inverter. The single phase bridge inverters are of two types: single phase half bridge inverter and single phase full bridge inverter. First we will discuss about single phase half bridge inverter. A single phase half bridge inverter. This is the circuit for a single phase half bridge inverter. A single phase half bridge inverter consists of two SCRs. Single phase half bridge inverter consists of two SCRs, two diodes and three wire supply. Two thyristors T1, T2 and two diodes D1, D2 and a three wire supply. Here the source voltage is Vs by 2. Okay, the diodes T1 and D2 are connected in anti-parallel with the thyristor T1 and T2 respectively. Okay, first we will discuss about the working of a single phase half bridge inverter with a resistive load. If our load is resistive, there is no need for the diodes D1 and D2. Okay. during the first interval, the input is a DC source Vs by 2. During the first interval, that is from 0 to t by 2 interval, from the time duration 0 to t by 2 interval, we are turning on the thyristor T1. We will turn on the thyristor T1. In these diagrams, the circuitry for turning on or turning off of the thyristors is not shown. The voltage waveforms are drawn on the assumptions that this is the output voltage waveform. The output voltage waveforms are drawn on the assumptions that each thyristor conducts for the duration its 8 pulses present and is commutated as soon as this pulse is removed. First, we will turn on the thyristor T1 by applying the gate current Ig1. Ig1 is given to the thyristor 1, then thyristor 1 will start its conduction. When thyristor T1 turns on, current flows through T1, output voltage V0. Okay, the direction of current and the voltage polarity is shown as figure. Therefore, the output voltage V0 is equal to plus Vs by 2 during this time interval. Output voltage V0 is equal to plus Vs by 2. Okay. At the instant t is equal to t by 2. At this instant t equal to t by 2, we are forcefully commutate the thyristor T1 and we will turn on the thyristor T2. Okay, when thyristor T2 turns on, we will turn off T1 and we will turn on T2. When T2 turn on at the instant t equal to capital T by 2, what happens? The polarity, output voltage polarity, the lower voltage source is connected with the load through the thyristor T2. Therefore, the output voltage polarity V0 is equal to, the polarity will become, here it is plus and here it is negative. That means the source voltage, the output voltage V0 will become minus Vs by 2. Okay, minus Vs by 2 when T2 turns on. Okay, here we are assuming a resistive load. Therefore, the current is in phase with the output current is in phase with the output voltage. Here we are assuming a resistive load. Therefore, the output current is in phase with the output voltage. Okay, this is about single phase half bridge inverter with the resistive load. In the resistive load condition, there is no function for the diode D1 and D2. During the first time duration, T by 2 time duration, we will turn on T1. Therefore, output voltage is equal to plus V0. Then during the second interval from T by 2 to capital T interval, we will turn on the thyristor T2. Therefore, the voltage polarity reverses. Here it is plus and here it is negative. It is plus and here it is negative. Therefore, the output voltage is minus Vs by 2. Since we are assuming a resistive load, the current is in phase with the voltage. Okay, this is about single phase half bridge inverter with the resistive load. Here we are employing forced commutation for the thyristor T1 and T2. We can vary the total time duration by varying the turn on and turn off time of T1 and T2. By varying the turn on turn off time of thyristor T1 and T2, we can vary the frequency and we can vary the total time period as well as we can vary the frequency of the output voltage. Okay. The load voltage, from this figure we can say that from the output voltage waveform we can say that the low voltage is an alternating voltage waveform of amplitude Vs by 2 and a frequency of 1 by capital T Hertz. The frequency of the inverter output voltage can be changed by controlling the time period capital T. Okay, this is about single phase half bridge inverter with the resistive load.